Okay, so here we are continuing on with notes. I know the previous video was fairly fast-paced, but I got to keep them under 15 minutes in order to be able to put them on YouTube. So please feel free to pause and take your time getting these notes down. So the shortcut that we just talked about was the side-side-side congruence postulate. Now, what we are going to talk about is the side angle side congruence postulate. So, the question that you want to be able to answer by the end of this video is, how do I apply side angle side congruence postulate to prove triangles congruent? How do I apply the side angle side congruence postulate to prove triangles congruent? So again, remember that these are shortcuts. Traditionally, if you wanted to be absolutely certain that two triangles were congruent, you would need to prove that all the sides are congruent and all the angles are congruent. Well, then comes along the side angle side congruence postulate. It says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So, to continue on, we're going to need to know, what does included mean? A way to define included, or to look at included, is going to be that it means sandwiched between. So if we look at our picture, the segment AB is included between angle A and angle B. So that is, AB is included between A and B. It's sandwiched between those two angles. So you can have an included side. You can also have an included angle. And in this postulate, we're really concerned about the included angle. So let's take a look at one. Here, part 4 says that A is included between side AB and AC. Now you should notice that there's some blanks for another description word that you need to know, and that is opposite. If a side or an angle is opposite to another side of an angle, that means it is not touching that side or angle. So using that definition, now when we're talking about opposite, AB is opposite of the angle C. that segment does not touch the angle C. And angle A is opposite BC. So I'm going to be using these descriptive words throughout the rest of the unit. So it's important that when I say what's the opposite side, that you understand that that's the side that's not touching the angle that I am referring to. Okay? So let's see with an example what this side angle side congruence postulate is really talking about. Let's see with an example. What it's saying is if RS is congruent to UV, that's what it's marked congruent to, and angle R is congruent to angle U, and RT is congruent to UW, then we can conclude that the triangles are congruent. We can conclude that RST is congruent to, remember, order matters. It is congruent to UVW. Why? Because we have two sides, side and a side, two sides, and an included angle. And so the postulate above says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this is explaining with an example the side angle side postulate. Let's look at these triangles and see if we can use this shortcut to prove that the triangles are congruent. So let's list out what we are given. Let's list out our given information. We are given that M marked with one tick, MN marked with one tick mark is congruent to the side OP. MN is congruent to OP. Well, it was given. It was already marked in our picture. We're also given that this angle right here is congruent to angle P. Now, there are 1, 2, 3 angles that have the vertex in. So if I want to talk about the angle that is congruent, I need to use its full angle name. Angle MNL is congruent to angle P. And we're also given that LN is congruent to NP. So this angle N is included between the two congruent sides. It is sandwiched between MN and LN. And again, here we have a side, we have another side, and P is the angle that's included. It's sandwiched between those two sides. So, can I say that these triangles are congruent? I sure can. I can say that triangle MNL is congruent to triangle OPN. Now, why can I say that? Well, I have a side, I have an included angle, and I have another pair of sides. So I have two sides of the included angle and the included angle of one triangle being congruent to two sides and the included angle of another triangle. So these triangles are congruent because of the side angle side congruence postulate. So we looked at our postulate, we explained it with an example, and we got some descriptive words. Now we're going to do a proof. Proof time. It's not that bad. Let's recall that to write a proof, a two-column proof, we're going to set up our columns. And on one side, we're going to write statements. And on the other side, we're going to write reasons. What is always, always, always our first reason? Given. Let's see what we're given. We're given that BC is congruent to DC. BC is congruent to DC. We're also given that AC is congruent to EC. We're given that two sides are congruent, and we're told to prove that the triangles are congruent. So far we only have two shortcuts, side, 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 and side, angle, side. We need to see which one we can use. What I want you to notice is side, side, side. I have to have at least three things that are congruent to each other. Side, angle, side. I have to have at least three things that are congruent to each other. What we are given are two things. We're given a side, pair of sides, BC, is congruent to DC. Given a side. We're given another side, AC, is congruent to EC. That was given to us. So I need to find the third thing. Based on our two postulates, we're looking for either another side that's congruent, or we're looking for an angle that's congruent. What you should be recognizing at this point is right here, we have a pair of what? Vertical angles. And if you look at those angles are included between the two congruent sides. And we're not going to write C equals C. It's not reflexive. It's not the same angle. They're different angles. We have angle BCA, and it's congruent to angle DCE. That is, angle BCA is congruent to angle DCE. Now, what's the reason? Why are those angles congruent? Well, because they're vertical angles. So now we have two sides and an included angle. So can I conclude that these triangles are congruent? Well, yes, I can. Triangle ABC is congruent to triangle EDC. Why? Well, because of the side angle side postulate that we just talked about. So, quick summary. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. This is called the side angle side congruence postulate, or SAS. Get that written